Good morning. Thanks for coming. We're going to talk about GKE Sandbox for multi-tenancy and security in this session. How many people went to the party last night? Oh, quite a bit. Thank you for coming after that, hard, playing around at the party. I kind of missed it, but we have a lot to kind of cover today, so let's get started. So first, we should introduce ourselves. Tim, you want to go first?
Sure, thanks. My name's Tim Kelton, and I'm the co-founder of Decart Labs. And I work on building tools to model and understand the Earth. And the other part of my job is doing all of our cloud architecture and our SRE and security teams.
All right, thanks, Tim. So then my turn. So hi, I'm Yoshi. I'm product manager on Kubernetes Engine. I work on G Visor, multi-tenancy, and machine learning stuff like GPU and cloud TPU in GKE. Next, Ian.
I'm Ian Lewis. I'm a developer advocate. I focus on GKE and container security.
Cool. Sorry, let's then begin. But before we begin, we would like to know about you as well. So let me ask this question. So how many of you think yourself as like an application developer or DevOps or SRE? Oh, many people, like I would say like 80% of people, okay? And then how many of you think as a security engineer, like folks, interesting, like 10 or 20%, I think, okay? How many of you actually wear both hats at the same time? There you go, my customer Tim here. Okay, that's interesting. So the reason I asked this question comes from my experience meeting with users, customers like yourself. I feel lucky that I can have an interaction with you all the time. And one thing I realize is that there are like two sides when I go to this kind of meetings. One side is like developers, application developers, DevOps, SREs who really care about speed and flexibility. Of course, those people who like containers and Kubernetes. And the other side, security folks who, of course, they deeply care about security, apparently. And as you can imagine, frequently I kind of feel that there are some challenges between these two groups when it comes down to making important like engineering and architecture decisions. For example, container or not, Kubernetes or not, sharing Kubernetes or not, clusters or not, right? So let's see that where this kind of a challenge comes from. We believe that's because fundamentally containers do not contain. We've been saying this actually from last year, but this means that while containers are really, really great for speed and flexibility to increase your productivity, it's actually not in a security isolation boundary for your workloads. That means that many, like a lot of you in this room, on the security folks or who are wearing both hats, have to harden the containers end to end. And that could mean a lot of work. You can certainly harden your containers through policies and do the right thing. However, technically, maintaining this or doing this right could be very, very challenging sometimes. We all know that security is critical, and it's also true that we have a lot of things to keep in mind. So there is a constant demand when I go to customer meetings. There's a constant demand about security that can we just do it in just one click? There's an easy way, which is totally understandable. In fact, open source software is growing. Everyone, I'm pretty sure, that is using some kind of open source, and that's really cool. A lot of features come in, and it reflects user voices very quickly. But when it comes down to actually using in production, using on your own, it's actually your responsibility. You have to, mostly security team, has to actually be in charge of assuring its integrity. Also, on top of that, the vulnerabilities around containers keep coming up, which I'll dig deeper. Most recently, there was a container escape in Runc. How many people kind of heard about this? Oh, yeah, this one's actually kind of widely mentioned, so it's pretty understandable. So just for to explain a little bit more, Runc is the engine of the container runtime, like Docker, containerd, and CRI-O. And in this case, if the attacker's process was running as root inside the container, the attacker was able to gain the root access of the host by overriding your Runc binary from inside. An obvious way to mitigate this threat was to run the container as non-root, of course, and apparently this is definitely sort of the recommended way running your containers in the first place. However, Now, even if you did run your containers as non-root, you still need to think about the container escape through the Linux kernel. So not many people know about this, but Linux kernel has a huge attack surface. And this type of container escape can happen by exploiting the bugs inside the Linux kernel. And if the attack was successful, the attacker may be able to bypass the container mechanism or elevate its privilege. One of the most well-known case of this is Dirty Cow. This is a privilege escalation using a bug in the Linux kernel. By exploiting a race condition in the copy and write system cow in the memory subsystem, the non-local user was able to increase their privileges on the system. So again, containers do not contain. Thus, you would definitely want to think about running only trusted code in your system. Going through, there you go. Now, if your system runs trusted code, you're following the right best practice and lower privilege. That's really great. However, in case of SaaS and multi-tenancy, things don't necessarily work that way. If you're running a SaaS, like Tim, my customer, your customers would like to upload their code to run their favorite plugins or on your service. In case of, for example, in our Google service, like Cloud Run could be a good example that we launched. If you have your functions or code and service containers, your custom users will be uploading whatever code they want to your system. And you, as a service provider, want to share a cluster to save the cost. As a consequence, basically, an untrusted code can be running on the shared cluster by default. Now, therefore, we need a solution, and there's a good news. There are containers actually do contain, and they are called Sandbox. Sandbox is a hot topic in Kubernetes. In fact, there are a number of sandbox technologies emerged in open source in just the last year and a half. And also in the Kubernetes world, Kubernetes runtime class was added to provide an API to access to this sandbox your containers, together with the new technologies that's happening in open source world. Now, open source technologies are coming up. And now the question is, do we have the product for that? With that, we're very excited to introduce GKE Sandbox on Google Kubernetes Engine. As the name says, it provides sandbox, containers do contain, to GKE. It adds defense in depth at the pod level. It is based on open source G Visor, which is what Google invented, and then also widely used in the Google internally. Now, since we open source G Visor, you might have heard about Google products that's using G Visor. Most recent one is the Cloud Run that we announced at the keynote on the first day. And one of the reasons that GKE Sandbox G Visor that's powering GKE Sandbox got so popular at Google is that it does not require any application changes. If you have your workloads, you have your containers, you don't necessarily have to change to get your stuff sandboxed. So if you're thinking about how to use this, you don't have to actually think about it. You just have to turn it on and then run your pods on GKE Sandbox. So how can GKE Sandbox help you? GKE Sandbox help you by, it's really easy to use. It adds defense in depth without hassling. First of all, it's part of GKE. The Google Kubernetes Engine is a managed Kubernetes service. And this GKE Sandbox is fully integrated into GKE. Thus, you don't have to install anything. You don't have to install open source G Visor. We already baked in everything. And we made the switch very simple that we're going to talk deeper. So if you have a container, if you're already on GKE, you just couple switch, and there you go. In addition to that, I just kind of mentioned, the technology used behind the scene is G Visor. And like I mentioned, You don't have to change your application. You don't have to change your applications or no new mental model to use it. You just run it as if you run your regular, your pods regularly. Second, it limits the potential attacks by reducing attack surface. Today, the container and the host operating system are tied together. What GKE Sandbox provides is our 2 layers isolation in between. Like this, I can't actually hold like this. But the first layer of isolation is the userland kernel written in Go that G Visor provides. And then even if that gets compromised, there's additional filter, seccomp, and namespace that would actually prevent further attacks. So from here, sitting together, to 2 layers in between. We're going to dig deeper on this one as well. Third, GKE Sandbox can help teams who want to run SaaS and multi-tenancy because it provides these strong isolation boundaries. For example, like Cloud Run that got announced again is using G Visor, the same technology behind GKE Sandbox. When you have such untrusted code come in here and there all the time, you do need isolation. Therefore, you want to think about this kind of technology, Sandbox, to be used in your system. So I think GKE Sandbox should be a great fit for those who are planning to go in multi-tenancy or who have SaaS similar to Cloud Run and many further services. With that, I'm going to hand it over to Ian to talk more about the technology backing up GKE Sandbox, which is G Visor, that is already in open source. Ian?
Okay, so I'm going to be talking about G Visor, which is the open source project that is what is used behind the scenes by GKE Sandbox. So G Visor is an open source project, container sandbox runtime. And what that is it's an OCI runtime, much like the Run C. That, if you're familiar with that, it's used extensively at Google for a number of different use cases. But as Yoshi mentioned, for cloud, it's used by for certain products that run untrusted code for things like Cloud Run. And our new App Engine runtimes. As an open source project, it's available on GitHub, and we have a lot of documentation available at gvisor.dev. So if you're interested in the project, definitely check out the website. We have lots of documentation on the architecture, the security model, and lots more. And we'll also we have mailing lists and a community meeting next week. So if you're interested in getting involved with the project, definitely checking it out. All of that information is on the community page on the website. So to give some background into G Visor and why we developed it and the thinking behind it, we wanted to be able to run untrusted code on behalf of users. But at Google, we use containers a lot as part of our infrastructure. And typically, the way that you would build a sandbox like this is you would use some sort of a hardware isolation mechanism, like a VM or a virtual machine manager. But that doesn't really necessarily fit with our architecture in a way that we liked. And we wanted it to be much more container-like. And for it to be something that really was very resource efficient at scale. So we obviously need something that provides us that defense in depth, that extra layer of isolation, but gave us a lightweight way of running a container. We wanted something that was very low overhead, something that was able to start and stop containers very quickly and easily. And we also wanted something that was zero configuration. So if you're not using a VMM, then usually you would do something like using AppArmor or seccomp, which tend to be based on configuration or filtering, and they depend a lot on how the application behaves, right? So you typically filter out the things that the application doesn't need to do. But you need to manage that configuration over time as the application changes, and it's very important from a security standpoint that you keep that configuration correct, right? Like if your application starts doing less things, you need to then update it so that the filter includes those things, and it's very hard from a security standpoint to make sure that all of the applications that you're deploying are managed correctly. And we also wanted to be able to run binaries unmodified. We didn't want to have to update our applications with a new library or link to a new thing in order to get the applications to run. We wanted to just be able to run regular applications that were built for Linux. So we built G Visor in order to solve those problems. And what G Visor does is it provides a user space kernel that is run in user space with your container. And as it runs your container or your container application, it intercepts the system calls that your application makes and handles those in user space. So in that sense, it's very similar to something like user space Linux, but it's a totally new kernel that's implemented in Go using the Go runtime. And we chose Go because it's a very good runtime. It provides a lot of things like garbage collection as well as type safety. So things that can help with the security of the user space kernel itself. And each pod is isolated with its own user space kernel, so we don't have a single user space kernel for all containers. And this keeps all of the containers isolated from each other. But by having this user space kernel, we're also isolating from the host, so that the host interaction is greatly reduced. And so we don't have containers interacting with the host and able to get host-level privileges. So diving a little bit deeper into the architecture for G Visor, G Visor provides an OCI runtime interface. So this is the OCI is the Open Containers Initiative, and this is a standard for running containers. And so we provide an OCI interface in the form of an application called runsc. And this is a single binary that you can use to deploy G Visor and install it. And so it's basically a drop-in replacement for the runsc binary. And when you run the container, we start up the container in user space with our user space kernel, and we call this the sentry. And then when the container runs, we use something called a platform in order to intercept the system calls and redirect those into the sentry. And we use KVM and ptrace as our two platforms that we provide as part of the open source project. And then on top of the sandbox itself, we have the sandbox held inside of a container, a normal host container, which is using setcomp and namespaces in order to further isolate from the host. So as Yoshi mentioned, we have two isolation layers. One is the sentry itself and the user space kernel. And the second is the host itself and the setcomp and namespaces that the host provides. And so in order to get control of the entire host, you would need to break through both of those isolation boundaries. In order to further add isolation, we have something called a gopher, which is a separate process that gets run when you run the runsc container, and that provides file I/O. So the sentry itself does not have permission to open files on the local file system. So even if you get control of the sentry, you're not able to write to the host file system and gain extra privileges that way. You have to go through a separate process that is the over 9p in order to write files and deal with file I/O. This gives us an extra layer because there's a lot of different types of attack surfaces and gives us that extra 2 levels of isolation for file I/O as well. So that's G Visor itself. How does that fit into GKE Sandbox and GKE? So with GKE, we provide a managed control plane, an API server, and then each of the nodes in the cluster is a GCE VM, and you can arrange those in node pools. So a node pool is a group of servers in your cluster or worker nodes in your cluster that have the same configurations, the same machine type and things like that. And you can have multiple node pools in your cluster. And so what GKE Sandbox allows you to do is create node pools that have G Visor enabled. So basically, an extra checkbox in the Cloud Console or an extra flag on gcloud enables you to create a G Visor enabled node pool. And then when you run your nodes or you run your workloads in the cluster and you specify G Visor as the runtime, then it will schedule and run your workloads on your G Visor node pool. So let's drill down into one of these nodes. Each of these nodes has an agent, the Kubernetes agent, the kubelet, and that kubelet is responsible for running the workloads on that VM or that worker node. And in order to run containers, it uses an extra runtime, in this case, containerd, which is a high-level runtime. And that in turn uses OCI to use a low-level runtime in order to run containers. So typically, this would be done using runc. But what we can do with our G Visor enabled nodes is to swap that out for G Visor. And this is enabled because we're using the OCI as a standard interface. So how do you use it from a user's perspective? So from a user's perspective, all you need to do is specify the runtime class name as part of your pod spec. Kubernetes provides what's called a runtime class API, which is a new API that allows you to find different runtimes that you can use within your cluster. And GKE Sandbox provides this automatically when you create a node pool that is G Visor enabled. So you don't have to worry necessarily about creating these runtime classes and managing those. Those are more of a system or a cluster administrator type of a role. But from a user's perspective or somebody wanting to run workloads, all you need to do is put this runtime class name of G Visor into your pod spec, and then that will get run in G Visor when you submit that to the API server. So what kind of workloads are good for G Visor from a technical perspective? So G Visor works really well for things like microservices, so things that are very small and quick and needs to come up and down and are highly scalable and are as well as dense. So things that can take advantage of the low overhead that G Visor provides work really well in G Visor. So if you're running microservices that make use of a lot of third-party code, perhaps you're using something like Node.js and you have a lot of external libraries that you're using, or pretty much any other type of language, running that in G Visor might be a way of better ensuring that you have some extra isolation there. It's also really good for SaaS and serverless workloads, so things that you're going to be running code on a user's behalf. So people upload some code and you run it on their behalf. Those type of things give you a little bit of extra confidence that you're not exposing your entire infrastructure to the code that gets uploaded. It's also really good for batch and machine learning workloads. So G Visor, because it's running as a user space kernel, it's running directly on the CPU, and so CPU-intensive workloads work really well for it. It also is really good for applications that run on this kind of complex user input. So user input that comes into the application and gets processed. Typically for things like machine learning and batch, that data is user submitted. So things like uploaded images or uploaded data. And you typically don't really want to think about all the different types of complex user input that could come in and whether well-crafted input could cause a security issue with your application. You'd like to be able to just run it in a sandbox and not have to think that much about the security implications. So let's take a look at the software as a service use case. So I'm going to switch over to a demo here. So what I've built here is I've built an application that is a WordPress software as a service. It's a very simple service that allows me to create a WordPress instance and run that WordPress on behalf of my users. But what I want to do is I want to be able to allow users to upload or install any plugins that they want to as part of their WordPress application. And those plugins can basically contain arbitrary code, right? So these are plugins that are available on the WordPress marketplace and are not really vetted by me in terms of like their security and that sort of thing. So what I want to do is be able to allow people to create their own plugins, to install plugins on the marketplace without having to worry too much about the security implications. So what I can do here is I can create a new WordPress and call that Ian's blog. And I can create any number of these. I'll create Yoshi's blog too. And what this is going to do, this is implemented as a simple controller in Kubernetes. So this creates a CRD that then gets kicked off and creates some pods for me in my cluster. And so if I go over here and I look at the state of the cluster, we can see that I've got 2 node pools here, and this is a listing of the nodes. I first have my default pool, which is just a non-G Visor enabled node pool, and then I have a second node pool that is enabling G Visor here. And so if I go ahead and get the pods that are running in my cluster, I can see that I've started the WordPress for my blog, and I've started the WordPress for Yoshi's blog. And we can see that the WordPress blogs are running in our G Visor node pool. We can also see that if we get the pod here, we can see that our runtime class name here is specified as G Visor. So that means that it's running our workload as part of the inside of G Visor itself. Great. All right, so our blogs are up and running. So let's go ahead and click on our blog here. And so what we'll have is like a brand new blog that's running inside of G Visor. And it's taking a little bit to connect here. Let's try Yoshi's blog. All right. So we go ahead and click English. Let's say the site title is Yoshi's blog. Create that. Hide this guy. Go ahead and install. And log into our new WordPress. And so this is a fully functioning WordPress site. And so what we can do here is we can go in and add new plugins. So we can install basically any plugin we want here, like a classic editor, and have that install and activate without having to worry too much about like what that actually contains in terms of the code that's included in it. So what I'm going to do here is I'm going to actually upload a new plugin that I want to install that my friend Tim gave me. This one's called Dirty Cow. I'm not really sure what's in it, but I'm just going to go ahead and install it because he said it's really cool. So if I install this guy, it installs successfully. OK, so let's go ahead and click on this activate here. When we do that, it kind of sits here and spins for a while. I don't know if you can see this, but it's sitting here and spinning. But if we kind of go into our logs, we can see that it's not quite up yet, but what this is doing in the background is it's actually running the dirty cow exploit as a, all right, here we can see it. So it's actually running dirty cow, trying to attempt to take over my WordPress installation. So we can see here we're running the dirty cow exploit, and what dirty cow does is it uses madvise and ptrace, the system calls, and running those in parallel in order to try to take advantage of the system and take advantage of a run of a bug in the Linux kernel in order to actually take control of the whole system. While this is kind of an old bug, and that most Linux systems are patched nowadays, this is just a good example of the type of class of bug that that G Visor can prevent, and that it helps mitigate. All right, so let's go back. Let's go back to the slides. Yeah. So next, I want to have Tim come up and talk about machine learning and the use cases around that and what he's been doing.
Thanks, Ian. You like my plugin? So I don't know if any of you have heard of Decart Labs, but we're a startup that's a few years old. We've about 4 years old now, and we're kind of focused on the area of machine learning and on being able to better observe the Earth. And our background is, we're kind of not a stereotypical startup. We're up in the mountains of Santa Fe, New Mexico, and we're there because myself and the founding team were out of Los Alamos National Laboratory. And there we were researchers in like high-performance supercomputing, astrophysics, and among them, we did research in things like machine learning and being able to apply that to remote sensing data. And we do that because, and we started the company to basically be able to understand how changes happening all over the world will start to impact our customers and their businesses, their organizations, and even their supply chain. And I don't have to go around and tell you there's a proliferation of sensors. All of you have phones, and you know all about IoT and things like that. And that's on the ground, but we're having that same parallel explosion in sensor technology happening on space. And so we're getting better and better resolution, more and more modalities, better temporal coverage, and it's just getting cheaper and cheaper. These used to be $500 million instruments that NASA put up. Now there's grad departments that are making these, and there's startups here in the Bay that are just launching them. So what that's going to do is that's going to change how we can observe and measure the Earth, and it's fundamentally changing a lot of the workflows. So a lot of the data sets we leverage are really scientific in nature. They come from places like NASA or European Space Agency, but more and more we're just seeing that hit on the commercial level. And this new type of workflow is totally different than historically what happened. Historically, you would have an analyst and they would pull down an image onto their desktop. Well, that worked great when you had 4 scenes that were captured once a month and things like that. But we've long passed when the images and the data that was being captured was humanly observable. And that's the type of machine workflows that we're trying to leverage. So things like drought and food supply and famine and water, precious commodities that go into building everything around us. Those are what impacts us. And so this is kind of this new digital twin of the planet that we're trying to measure and understand. And we have, probably nearly 20 petabytes of data now that's stored up in the cloud that we run and iterate on models. So that's great. We never could do that before without the cloud. But it does create some challenges. What we did was originally make these APIs for our own machine learning team so they could scale up and test data sets, test models against these huge data sets. When we run so we built our SaaS platform, obviously on the cloud. And often it's not just those data sets that our customers want to use. They want to build their own models. They want to often use one of their pieces of data to get new insights for their company. So I thought I'd show you some examples. Warning, this is going to be lots of pictures. Hope that's okay. It's Thursday. So this is a solar facility in Morocco. It's pretty amazing to look at. But often it's temporally how things change that give us those insights, and we need to be able to understand. So obviously this is a construction and the building of that facility. Another example is showing, patterns of life. Often we need to fuse together different sensors and not just one. So in the top row is just normal red, green, and blue, like all of us as humans can see. But the bottom row is fusing together infrared. And you notice on the far bottom right, one of the big things you can't see with just human visible light is that thermal signature. We do this for all different types of examples. We're starting to now run a wildfire detection algorithm that will run over the entire western half of the US. We don't know exactly where a wildfire might happen, but being able to detect those thermal signatures is important. This is another example. This is more in the kind of computer vision and types of things that you would use, TensorFlow or those types of tools. This is a model that can detect buildings and structures. And last fall, there were some hurricanes that were heading toward Florida. And so we were saying, well, could we actually scale this model across the whole state of Florida? So that took us a couple hours. And that's across hundreds of terabytes of data. So why might you also want to use or know about where all the buildings are being produced? Well, construction takes raw materials, and those correlate into commodities and demand structures. So in this case, steel. And again, this is just things that weren't really visible or weren't very easy to measure without tremendous amounts of computing power and that massive data that's being collected. Water, already talked about that a bit once before. This is a different modality. We're sending a radar signal down to the Earth. It bounces off the Earth's surface. It gives us almost a height measurement. You can see heights in reservoirs and areas like that. You think about how many areas water is an input to a pattern of life. So that's everything from food and food supply and the types of models we build there. And those of us that live in places like the western half of the US, New Mexico, California, we know how volatile water supply can be. Once you know about buildings, you might care about trees or encroachment of trees. Looking down and being able to identify a tree versus vegetation is actually really hard. They both look like vegetation that's growing. There's photosynthesis occurring. You can see both of them the same. This is a place where we were able to take LiDAR to train and see the height, and then be able to differentiate and apply this to places where we didn't have LiDAR coverage, and basically run this over the whole globe. And again, you think about last summer out here in California, look at some of the devastating fires. We were able to scale and run this model and map out every single tree in the entire state of California. So that's just, it took lots and lots of computing horsepower and lots of storage. But these are just a couple quick examples, and I really show them just to point out how wide the use cases are, how varying the data sets are. Now think how different the code and the models have to be. There's not just a magic model, and there's not a magic data set. So when our customers are building these types of models, what are they coming to us and asking for? Well, they care deeply about the physical world. A lot of them are Fortune 500 companies. They care about physical infrastructure. But a lot of them are very concerned about security as well. We all are. And often they're wanting to train a model, so make their own intellectual property off their data, which is their intellectual property, And they want to know that their model is isolated from other customers and it's safe and secure. And so we want to enable them to be able to build and train and test those models about all of our petabytes of data. So it kind of has to live next to the data. And know that the security isolation isn't going to slow down or cause delays in the training. And then they want to have confidence that they'll be able to, that other users of the system aren't going to be able to access their data or their intellectual property. So what challenges do we have when trying to build that type of a platform? Well, each model is executing someone else on one of our users' machine learning code. So we need to be able to execute that securely and at scale. Each model has very different requirements. Some of these models are very CPU intensive. Others are very memory intensive. Maybe some of them need to use a GPU. These are pretty big in scale. I'll come in most mornings and I don't see 10 or 20 cores running on our Grafana graph. I see tens of thousands of CPU cores that are running, that somebody's going out and building models or testing models against those data sets. So it needs to scale and be efficient. And we thought originally of doing this through isolating with GKE node pools and making one node pool per customer. But that kind of runs into a lot of limitations once you start getting a few customers. We thought of using a cluster, a whole Kubernetes cluster per customer. That also runs into a lot of limitations. And we wanted to do this, we're a startup. We don't have just infinite resources. Most of you don't either. And so we're trying to do this as efficiently as possible from a cost perspective and still get that security. So we want to leverage Kubernetes scheduler to get that really tight bin packing. So on GCP, there's a lot of great tools for data and things like data exfiltration. We leverage things like VPC service controls to prevent data exfiltration. But for models and model execution, we need to execute that user's code. So the first thing we do is we carve out a user namespace for each user. And then we restrict what they can talk to. They cannot talk to the Kubernetes control plane under the hood. They can only talk to our Decart Labs APIs. So that's a really important separation. And then our Decart Labs APIs are talking to the Kubernetes control plane, and that's how we're scaling up and down the workloads. And then for our Decart Labs APIs to get visibility into what's going on, to be able to do things like rate limiting or security, telemetry, that's all handled through Istio. Our user workloads, as Ian just showed, those go in a GKE Sandbox node pool. And so, as it's been mentioned, that improves a lot with security. It limits syscalls to the kernel. It separates each user. And it's a lot more efficient than making their own node pool for every single customer. For us, we get much improved on the cost side. We run most of our workloads on things like preemptible VMs, so that's critical to be able to use that and make that efficient in terms of pricing. And we get the tighter bin packing of those workloads and still improve isolation. So how did we enable GKE Sandbox? As was mentioned, you basically set the sandbox type to G Visor when you do a node pool creation. And what's really great was we didn't change our code. We didn't have to have our users change their code to get this degree of isolation. And we could run this on an existing cluster. We simply just made a new node pool. So it's very easy to get this started and just start testing your workloads and see how they do. So the next question you might say is, well, how did it actually perform for these types of machine learning workloads? The basic test case, we've only tested this on a few workloads, but the startup cost is around about a second. And we're running models in minutes to hours to days, so we can live with a second. And then those rough models are about 1% difference in terms of overall performance. So, I mean, to be honest, I would say that's within the margin of error in our measurements. So that's more than adequate. And so this is now available, and we're making this available to all of our customers today. And with that, I'll hand it to Yoshi.
Thank you so much, Tim. It's great to see this is not like a demonstration, it's running in your real system, seeing the value. So as Tim quickly touched, I'm going to dig a little bit deeper into the performance. To set the kind of tone correct, GKE Sandbox isn't about like boosting your performance. It's all about like providing isolation. And providing that sort of isolation and additional defense, we're going to take some cycles from your workloads and get back this defense with ease, and which will lead to the cost efficiency that Tim just described. So for machine learning workloads like Tim introduced, yes, these are this is a kind of data from the machine learning inference workloads or prediction, and these types of CPU and memory kind of oriented workloads, the cycles that we need to provide to give you back the isolation that Tim talked about are roughly about 2 to 3% of the overhead. So if you're wondering, like, the workloads, like you have similar workloads like Tim's, this should be a very good fit for you because with just only 2 to 2% of a cycle, you get these kind of benefit upfront. Now, workloads like Redis, I think we know a lot. A lot of you may know about Redis, in-memory data store, one of the most popular staple workloads on GKE. These type of workloads need 20 to 30% of cycles from from you. To return the benefit. But if you have like SaaS and multi-tenancy, for example, if you have Redis instance for each customer where today you create a different cluster or nodes even, then GKE Sandbox should still be able to help you greatly to provide you this the bin packing capability with ease. Lastly, I'm going to show about the FFmpeg and then WordPress use case. So FFmpeg is a well-known transcoding open source program, and WordPress, as Ian already showed, is a blog and website web hosting platform. They are actually both network and file-oriented workloads. However, the way they do the I/O are actually different. Compared to WordPress, which will issue I/O one by one, FFmpeg actually gathers I/O very nice way so that GKE Sandbox doesn't have to take too many cycles from you. It's only about 5% to actually 5% is pretty much the cycles that we need to give you back this isolation, which will lead to the cost efficiency. So if you're wondering like I'm now interested in GKE Sandbox, but which workloads will be the great fit? Actually, this few number I/O should be a very good guideline to figure out to find workloads that will be very kind of beneficial by using GKE Sandbox. Okay, just wrapping up then. So we introduced GKE Sandbox. This will be publicly available in late April. All the things are queued up, waiting for after next to unlock everything. GKE Sandbox will provide defense in depth to your Kubernetes pod with ease. No application changes, like 2 lines, which Tim showed is exactly what you have to do. It will be great for a team interested in SaaS and multi-tenancy. And it's based on open source G Visor, which Ian talked about, and we put a lot of effort into providing better experience as product. All you have to do is to just create a node pool and turn it on in your prospect. Rest of the things will happen behind the scene. And we also add actually a lot of optimization around performance. So if you're wondering which workloads to use for GKE Sandbox, please take a look at the numbers that I kind of shared today. That's pretty much it. Thank you very much for listening. If you have any questions, please comment. We only have like less than a minute. More than happy to take the questions offline. So feel free to come to hit us. Thank you so much.